Hi, and welcome to this video that teaches you how to solve all the problems in the Exam 2 study guide. The first problem asks us to find all values of x for which the rational expression is undefined. Recall that a rational expression is undefined when we try to divide by 0. So for example, if we had 6x plus 5, right, over 0, or if we have 5 over 0, that's when an expression becomes undefined. So what we're going to have to do is we're going to have to find all of the values that would make the denominator equal to 0. So we're going to write the denominator x squared plus 9x plus 18 equals 0, and then we're going to factor it. So in this example, we have a trinomial. We can use the AC method. And when we do that, we end up with x plus 3 and x plus 6. Then we use the product property of 0, and we set both of these factors, x plus 3 and x plus 6, equal to 0, and then we solve. So over here, we subtract 3 from both sides, and we find that if x is equal to negative 3, that is going to cause the denominator to be equal to 0. Over here, we find that if we let x equal negative 6, that will also cause the denominator to be equal to 0. So the two values that would cause the denominator to be equal to 0 are x equals negative 3 and x equals negative 6. If you like, you can also express it this way: x cannot be equal to negative 3 or negative 6. Either way, it would be fine. Let's move on to the next problem. So in this problem, we have to first find and state the restricted values, and then we're asked to simplify the expression completely. So as you can see here, we have a trinomial in the numerator and the denominator, so we're going to have to use the AC method in both places. So we're going to have something that looks like that in the numerator and something else that looks like this in the denominator. So in the numerator, I believe you get x plus 2 times the quantity x minus 1. And in the denominator, you're going to end up with x minus 4 times x plus 2. Remember, you can always FOIL those and fact check yourself and make sure that they are factored correctly. So at this point, you might be tempted to cancel things out. But there's a step that we have to take first. So we factor everything, okay, and before we start canceling things out, we have to identify our restricted values, okay? And remember, just like from problem number 1, the restricted values only come from the denominator. They don't come from the numerator. I can have 0 over 1 because that's just equal to 0. It's okay if the numerator equals 0. It's only a problem if the denominator is equal to 0. So I can't let x minus 4 be equal to 0, and I can't let x plus 2 be equal to 0. So, solving both of these, we find that our two restricted values are positive 4 and negative 2. Okay? So this is going to be important in a second. It's actually going to be part of our overall solution. Okay? So now that we have our restricted values, now I can cancel out terms. And I will do that using maybe a green pen here. So the x plus 2 terms cancel out, and I am left with x minus 1 divided by x minus 4. But then remember, I need to write a comma and make a note that the restrictions are that x cannot be equal to 4, and x cannot be equal to negative 2. Okay, so that's very important because those restrictions still apply to that expression. All right, let's do another problem. In number 3, we have a doozy of a problem. We have a bunch of polynomials. So the first thing I'm probably going to do is I'm going to factor all 4 polynomials. So this is really nice because it's some good practice for chapter 1. So after you go through chapter 2, you probably won't need to go back and study chapter 1 because you've done so much of chapter 1 already in chapter 2. So x squared minus 2x minus 15, we're probably going to use the AC method there. That's going to give us x minus 5 times x plus 3, x squared plus 4x plus 3, x plus 3, x plus 1, and then 20 is going to be x plus 4 and x plus 5. Now remember, if you'd like to, what you can do, it's kind of fun, is you can get rid of this multiplication sign and you can just morph it into a single fraction, just like that. Now at this point, it's super tempting to cancel things out because already you can see terms that are both in the numerator and the denominator. And it's so exciting and you're so ready to cancel things out. But remember, what we have to do first is we have to find our restricted values. So how many terms are we going to have? How many restricted values? Well, it looks like we have 1, 2, 3, 4 restricted values. So based on this, it looks like x cannot be equal to positive 5, negative 3, negative 4, or negative 5. And if you want to take the time to show your work there, you're welcome to do that. Okay, now that we have our restricted values, now we can go through and cancel out terms. So it looks like there's an x minus 5 here that cancels out. It looks like there's an x plus 5 that cancels out. And it also looks like there is an x plus 3 that cancels out. So it looks like all that's left is an x plus 1 over x plus 4, okay? But remember, we need to write a comma and we need to mention that this expression is only defined, or it is defined for all values of x except for these 4 values, okay? And again, that's very important. All right, let's do another problem. So in this problem, we have a similar thing. The main difference, hopefully you can see, is that there is a division sign here. So the first thing I'm going to do is I'm going to rewrite this expression as a multiplication problem. You don't have to do this if you don't want to, but I would strongly recommend that you do this so that you don't forget to do it later on. Okay, and I'm going to write in red the things that are changing. So remember, when you have a fraction divided by another fraction, we do keep, change, flip. So we keep the first fraction, we change the division sign to a multiplication sign, and then we flip the second fraction, and the denominator moves upstairs to the numerator, and the numerator moves downstairs to the denominator. So that's the first thing I am going to do is, again, rewrite this as a multiplication problem. Now that I've done that, I'll take some time to factor these 4 different polynomials. So x squared minus 4 is a difference of squares. X squared minus 3x plus 2 is going to be x minus 2, x minus 1. X squared plus 3x minus 4 is going to be x plus 4 times x minus 1. And x squared minus 2x minus 8, I believe, is going to be x minus 4 times x plus 2. Again, if you're unsure, you can always FOIL any of those and check them. Okay, so again, at this point, you start seeing terms that are present in both the numerator and the denominator, and it's super tempting to just start canceling things out. But remember, we first have to take some time and identify our restricted values. Okay, so we have 1, 2, 3, 4 unique terms here. So we find that x cannot be positive 2, positive 1, positive 4, or negative 2. So now that we have our restricted values, now we can start canceling things out. So x minus 2 looks like it's going to cancel out. What else? X minus 1 looks like it's going to cancel out. And x minus 2 also looks like it's going to, x plus 2 also is going to cancel out. So what's left? Well, it looks like all that's left over is x plus 4 over x minus 4. But remember, this expression is only algebraically equivalent to our original problem if we also include the fact that x cannot be equal to any of these 4 values. And again, that's very important. If you leave that out, your answer is incorrect. All right, let's do the next problem. So in this problem, we're asked to simplify an expression with two fractions, and you might notice that each fraction has a different denominator. So just like when we add 1/2 plus 1/4, we need to find our LCD. So before I find my LCD, what I'm really going to have to do is I'm going to have to factor my denominators. So p plus 1 is fine. I don't really need to factor that. What I really need to factor is p squared plus 3p plus 2. So I strongly recommend anytime you do problems like this, even though it takes a little bit of extra time, that you rewrite the whole problem every time so that you don't forget parts of it. So if I factor p squared plus 3p plus 2, you get p plus 2 times the quantity p plus 1. So now that I've factored, I can clearly see that my LCD is p plus 2 times p plus 1. Okay, so now I need to have a common denominator. I need to do some work to obtain that in both fractions. Again, just as if you had 1/2 times 1/4, you'd have to multiply this, so it becomes 2/4 plus 1/4. So we're going to do the same thing over here. So the first fraction already has the LCD as its denominator. The second fraction is missing a p plus 2. Now remember, we multiply the p plus 2 on the top and the bottom because that's really just multiplying by 1. And multiplying by 1 doesn't really change anything. 5 times 1 is just 5. So what I can do is I can rewrite this like this. Okay, and then I'm going to rewrite it one more time so that the numerator, just like I might rewrite 2/4 plus 1/4, I might rewrite that as 2 plus 1 all over 4. I'm going to do the same thing over here and add my numerators. Sorry, I'm going to distribute this. So it's going to be 6p plus 12. And then I'm going to express this over a single denominator, again, because they have the same denominator. Okay, so now in our numerator, hopefully you can see that there are some like terms. So specifically, we have a 10p plus a 6p. That's going to give us 16p. Likewise, we have a 4 plus 12. That's going to give us 16. So we have 16p plus 16 divided by p plus 1 times p plus 2. Okay, so at this point we could factor out a 16 from the numerator, and we would have something that looks like this. Now again, at this point it's very tempting to start crossing things out, but what we have to do first is we have to find and identify our restricted values. Okay, and our restricted values, or those values that would make the denominator be equal to 0, are -1 and -2. Now that I found my restricted values, I can go through and I can cancel out this term. So my final answer is 16 divided by p plus 2, okay, given that p is not equal to -1 or -2. Okay, so this right here is my final answer. Okay, so let's stop there and we'll pick up on the next problem in part 2 of this video.